This segment brought to you by Bravo Company USA. Larry Vickers, Vickers Tactical Channel here. I've got my good friend Paul Buffoni of BCM. We're at BCM's new facility, and we're going to take you through a quality control piece that we've been working on for quite a while, well over a year. So quality, you would have to say, is frankly an obsession of BCM.
Absolutely, Larry. Without quality control and our obsession for quality control, we're just another AR rifle manufacturer. When we got into this space, our mission was to serve that professional community, to manufacture professional grade weaponry, products that could and would be in harm's way. As such, we approach our space in this market as life-saving equipment, not a sporting goods product. So for life-saving equipment, the quality control measures are going to be extensive and obsessive.
And you could even say, really, objectively, that lesson you learned real early on with the famous barrel episode, that was really a blessing in disguise, because you learned a hard lesson early on versus having to learn it down the road.
Right. And it sets you up. I mean, a lot of times you learn by some of your mistakes. It can be a great teacher, great motivator. Over the years, we've brought more and more things in-house. We control our own prints, we control our own engineering, we control our own designs, and we control our own quality control inspection. And what we've brought to that area is really many things are very much outside the box of the firearms industry. Much of it was taken from aerospace and implemented into our product line here for safety.
Okay, so we're just going to get a little taste of some of the BCM's quality control measures, just a little taste.
Just a tiny bit to get a comprehensive overview of the entire process. We would be here for some time, probably a few weeks, but at least we can just take a peek at some of the processes going on.
Okay, so let's kick off with bolt carrier.
We'll start with the bolt carrier group, or the bolt carrier. It's the heart of the weapon system, the engine of the weapon system, probably the most important single piece. The most difficult piece to manufacture, and the most problematic in the field.
Good deal. All right, to kick this thing off now, Paul, this is a bolt carrier.
Yes, sir.
All right, no carrier key, no finish. This is your first initial inspection procedure for the bolt carrier of M16, M4, AR-15. This is it.
That is correct. It does not have phosphate, it's in the white. However, it does have chrome plating on the inside diameter, the bore where that bolt and the rings are going to run.
Got it. And what do we have here?
What do we have here? This is a bore scope. It's commonly used for barrels. There's a camera and an illuminator that goes all the way into the end here, and then the inspector can look inside of that bore as he rotates the shaft. And what we're looking at in here is the chrome. We're looking at the chrome to see if it's flaked, if it's chipped, if it's missing. We're going to look for burrs, we're going to look for tool marks, we're going to look for anything that can impede the movement of the bolt inside of that carrier.
And correct me if I'm wrong, so everybody understands this, how smooth that finish is very, very critical. Very critical,
just like a combustion engine. The cylinder on a combustion engine needs to be honed to a certain surface finish. This is much the same. The process after this is a profilometer where we're going to measure the surface finish of the interior of that bore to ensure it meets the minimum specification for smoothness.
Good deal. Now, first initial phase, bolt carrier doesn't pass this, it's gone.
It's gone.
Right. Got it. This bolt carrier, let's say, is passed. Now we're moving down the line. We got another station set up.
Okay, after we inspect that surface finish, we're going to look at the inside diameter of that bore, also critical. And that's the next inspection station we set up.
All right, bro, let's do
okay.
it.
Next, we're going to look at the three inside diameters inside the carrier group. This graphic shows just exactly where they're located and how critical they are. We've got the shoulder run area that is going to receive the shoulder of the bolt, the ring run area in yellow here that's going to receive the rings, and then the boat tail, which is going to run toward the rear. All three of those diameters have to be concentric with each other. If they're not concentric, you're going to have a gas leakage problem, a premature wear problem. Provided they're concentric, the inside diameter of those also has a very tightly controlled specification for that bolt to run inside. And we're going to check it right over here with this tool that we designed that interfaces with an air gauge.
Now, important to note also, this is another 100% inspection. Every bolt carrier that gets BCM on it has this.
Yes. Before the logo goes on, it's 100% inspection.
Good deal. Let's check it out.
Okay. We use the air gauge. It's simple to use. It's very, very precise. This is the fixture that we designed. You simply drop the carrier group onto the fixture and look for the 3 green lights as the air gauge reads the inside dimensions. It's been programmed with the correct specifications. So this carrier, all 3, good to go.
And then if it's out of spec, it'll read red.
Yes, yeah. If it's out of spec, you get a big red line here, 1 or 2 or 3 of them. A big red line here, and then it's scrapped.
It's got it scrapped. Good deal. What's next?
Next, we'll look at the exterior gas system. We'll look at the gas block, the gas tubes, and the gas carrier key. Okay, now we're going to look at the exterior of the gas system. This graphic shows some of the areas. We're going to look at the gas key, we're going to look at the gas tube, we're going to look at the gas block, and of course the barrel that where the gas block would mount. All of those areas where the gas system is going to run are going to be critical dimensions to check to ensure proper operation and proper function of that rifle. First area we're going to look at is the barrel. We're going to use a laser micrometer. The area of the barrel where the front sight base or the gas block runs is held to 7/10. Not insignificant on a barrel that's been machined, it's been media blasted, and it's been phosphated. It's a post-plating measurement. We're going to measure every single barrel at BCM before it goes into an assembly. So the way the laser micrometer works is it scans that area where the gas block sits, and on this particular one set up in the fixture, we've got the green go light. Of course, if we move the cradle, we'll get the no-go light, and we'll get the large audible because it's off of that area.
Move it back into green.
In the green, we're good to go. This barrel is in spec. This machine has been pre-programmed with the specifications for the lightweight barrel or the heavyweight barrel.
And pretty easy to use.
Very easy to use and very precise.
Good deal. Okay, next up.
Okay, next thing we could look at is the gas tube. Gas tube has got 3 areas that are going to interface with the rest of the weapon that become critical. The flare on the end, which goes into the gas key, and these 2 areas right here that seat inside of your gas block. We're going to look at these through this air gauge technology and this fixture that we developed and built in-house. Also, we need to look at the gas key, and also we need to look at the gas block. The gas block has 2 areas that become critical, one where the barrel is going to run through, and the other where your gas tube is going to run through. And using the air gauge, we can inspect all of them. So gas block inside diameter, we've got green, we're good. Gas tube ID, where the gas tube runs, again, we're up on top here, we've got green, we're good. And I can't emphasize enough how critical this kind of stuff is. If these diameters are oversized, well, if they're undersized, probably won't assemble. If they're oversized, it'll assemble, it could feel okay, but if you're allowing that extra space there, you're allowing gas to leak. Gas to leak changes the equation. It's going to bring that cycle rate down. You're going to see intermitting weapon failure or intermitting short stroking or permanent short stroking. Obviously kind of a big deal on a weapon system that runs on a direct impingent gas.
Yeah, and that's something people need to be aware of is this gas system has to be a sealed system in order for the bolt carrier to operate, to get the projectile out of the barrel. It's much less forgiving than other gas piston designs.
Yes.
Because it has to more or less stay a sealed system with minimal leakage.
Right. Especially less forgiving for the manufacturer.
Yes.
If you can hit the tolerances, it's incredibly reliable. But when you don't hit the tolerances, you're going to have intermitting issues that you're going to pull your hair out about.
Yep, good deal. Now, some of this stuff has actually been used by other, military, government entities, right?
Our process is quite a bit broader than we're looking at here. We're kind of looking at the tip of the iceberg. There's just a whole selection full of other inspections and procedures and processes we've developed. In working with some of our partners in the industry, we have adapted some of this technology whether it's prints, whether it's process, whether it's direct tooling that we've built into some of Uncle Sam's supply chain for vendors dealing directly with the DoD.
Good deal. Now, another thing to keep in mind, just because you go to a gun shop and you see a gun that might look good on the rack, remember, it's not about externals and fit and finish. That may be important, but really it's what's going on inside the gun.
Yeah, fit and finish is something you can observe at the shop, and it is important. However, the area that we're obsessed with is the mechanical quality. We're going to be obsessed with the fit and finish of the interior of this gas block, the fit and finish of the interior of that gas key. Things that will cause that weapon either to save your life or fail. That's where we're gonna focus all of our time and energy.
Well, brother, as always, good to see you.
Thank you. Good to see you, Larry.
I appreciate it. Hope you enjoyed it. This is why I use and recommend BCM. Have a good one.